Hello all, welcome to new session. Today's new chapter is electromagnetic waves. This chapter is very smaller and very important chapter concerned to further study of ray optics and wave optics. Mainly in this chapter we are going to discuss what are electromagnetic waves, what are the properties of electromagnetic waves, and what is the correction of Ampere Circuit Law. That concept we will see. Before that, in simple way I can say what is mean by electromagnetic waves. See here, whatever light coming from sun, those light we are calling electromagnetic waves. From the sun, actually 7 types of radiations are coming. Those radiations we are calling electromagnetic waves. Already we know that if one field changes, one field mean if electric field changes with the time, magnetic field is produced, or magnetic field changes with the time, electric field is produced. I mean, if one of the electric field changes with the time in the space, other field is produced. That is responsible for electromagnetic waves. I will come to the point electromagnetic waves later on. Before that, let us remind what is mean by Ampere Circuit Law. Students, already we know that current is how to define rate of flow of charges. Wherever charges are flowing, I mean electrons are flowing in the conductor, which is responsible for the current. And in moving charges and magnetism chapter, there what we have learned, wherever current flows in the conductor, around it field is modified. That field we are calling magnetic field, right? So in electromagnetic, in moving charges and magnetism and electromagnetic induction chapter, there what we have learned, wherever electric field changes, magnetic field produces. In electromagnetic induction chapter, what we have learned, wherever magnetic field changes, electric field produces. I mean, if electric field changes, magnetic field produces. Wherever magnetic field changes, electric field is produced. But here we are going to deal one more limitation of Ampere Circuit Law. Just I want to remind what is meant by Ampere Circuit Law and what is its correction, that we will see. See students, Ampere suggested that, let us take it is nothing but current carrying conductor. This is conductor. In this conductor, consider this much current is carrying, right? Say this current is constant. This current what we are calling? This current we are calling conduction current. Conduction means the current which is responsible due to the flow of electron. That current we are calling conduction current. See, in this conductor, this is conduction current flows in the conductor. Wherever current is flowing, around it field is modified. How the field is modified? If you take very small pieces of iron, say iron filings, if iron filings are spread out around current carrying conductor, those arrangement gives the magnitude and direction of magnetic field. Look at here. What we know that wherever current can flow in this conductor, then how the field can modify? Field can modify like this. Like this field is modified. This field indicates magnetic field around current carrying conductor. See here, how the magnetic field is there? Like this nature magnetic field is there, and this magnetic field is non-uniform, not uniform. Direction of magnetic field and direction of current. How to give direction of magnetic field and direction of the current can be given by right hand thumb rule. If current carrying conductor held in the right hand, thumb point towards direction of the current and tip of the finger and circle gives direction of magnetic field. How it is? Look at me. If this is nothing but current carrying conductor held like this, thumb indicates direction of current and tip of the finger and circle gives direction of magnetic field. How the magnetic field is there? Like this magnetic field. This is magnetic field around current carrying conductor. How to give the direction? So at this point magnetic field is like this direction. At this point magnetic field is like this direction. I mean, at this point magnetic field is directed into the plane. Magnetic field directed into the plane. And at this point magnetic field is directed away from the plane like this. Right. But let us see what is mean by Ampere Circuit Law. Look at me here. We know that in this conductor, how much current is carrying? This much current is carrying. Are you following that? Right. So around it magnetic field is produced by what value? Say this is magnetic field value. Now on this imaginary loop, just I want to take very small length. This we are calling small length, infinite length, I can take this in current element. Then what Ampere circuit law? Line integral of magnetic field mean? See here, this scalar product of magnetic field and length of current element. This we are calling line integral of magnetic field. Now it is a closed path. This is a closed path. What I can take? Line integral of magnetic field over a closed path can be given by what value? Dot product of magnetic field and length of current element. Small length. What Ampere circuit law says? Line integral of magnetic field around current carrying conductor, I mean line integral of magnetic field around any closed path. This is the closed path. Are you following this? Line integral of magnetic field around any closed path is equal to mu naught times current enclosed by closed path. Line integral of magnetic field equal to mu naught times current enclosed by closed path. This is what? Ampere circuit law. I mean, wherever constant current is flowing, that Ampere circuit law can be given like this. This is what we are calling Ampere circuit law. But James Maxwell argued that there is inconsistency exists in Ampere circuit law. I mean, this Ampere circuit law only valid wherever this current is constant. Current is constant. Wherever current constant, then only this Ampere circuit law is valid. We know that wherever conduction current can flow, magnetic field is produced. This much magnetic field is produced. But Maxwell argued that wherever electric field changes, it produces magnetic field. What we know that wherever current is flowing, magnetic field is produced. What is Ampere circuit law? Ampere circuit law calculated magnetic field around current carrying conductor. Magnetic field around current carrying conductor, that current is due to only conduction current. Maxwell only able to find magnetic field produced by current carrying conductor. But Maxwell failed to explain wherever electric field changes with the time. Electric field changes with the time, there also current is produced. That current we are calling displacement current. Then initially some inconsistency exists in Ampere circuit law. What is inconsistency exists in Ampere circuit law? That we will calculate. See here. Now our point is displacement current directly. Displacement current. Look at me. We need to term the displacement current. See here. Concept is displacement current. Concept of displacement current. Before that, let us see inconsistency in Ampere circuit law. What is inconsistency? That we'll see. Very simple. So our point is inconsistency. Inconsistency in Ampere circuit law. In Ampere circuit law. Ampere's circuit law. Ampere's circuit law. Look at it. This inconsistency arises. Already we know that wherever current is flowing in the conductor, around it magnetic field is produced. Magnetic field produced around current carrying conductor can be calculated by Ampere circuit law. But Maxwell argued. What he argued? Wherever electric field changes, there also current produced. That current unable to find by Ampere circuit law. That we'll see. The inconsistency of Ampere circuit law can be studied by taking a parallel plate capacitor. How it is parallel plate capacitor mean? We know that the arrangement of two conductors separated by dielectric medium. This is nothing but one parallel plate. In simple manner, this is one parallel plate, right? I can take this is another parallel plate. Are you following? So these parallel plates connected by conducting wire. Look at me. Wherever current is flowing in this conductor, this current we are calling conduction current. I mean flow of current due to electrons. That current we are calling conduction current. Wherever current is flowing in this conductor, so it is connected by capacitor. Then number of charges are deposited. How it is? So on one plate positive charges are deposited. Positive charges are deposited. On another plate negative charges are deposited. Negative charges are deposited like this. We know that in between plates of capacitor electric field is constant. When electric field is constant, after charging these plates of capacitor electric field is constant where in between the plates of capacitor. But here wherever current is flowing in this capacitor, always more number of charges are deposited on the plates. Wherever more charges are deposited, then electric field is produced between the plates of capacitor. That electric field is variable. That electric field is variable. How it is? Look at me. Wherever current can flow in this conductor, how the electric field produce? Electric field is not uniform. Instead, electric field can changes with the time. How it changes with the time? Because as current can flow, more number of charges are deposited on the surface of the plates of capacitor. Say on one plate positive charges are available, on another plate negative charges are available. Right or wrong? So here which is produced? In between the plates of capacitor electric field is produced. This electric field is always variable value. How it is? This is always variable value wherever current can flow in the plates of capacitor. Now our point is inconsistency during that Ampere Circuit Law. What is inconsistency? That we'll see. We know that in between plates of capacitor only electric field is exist but not current is exist. Already we know. Because what is parallel plate capacitor? The arrangement of two conductors separated by insulating medium. Insulator doesn't allow to flow the current. Right? Or arrangement of two conductors separated by dielectric medium. Dielectric medium doesn't allow the charge, doesn't allow to flow of the current between the plates of capacitor. The property of dielectric it is only to allow the pass electric field lines but never allowed to pass electric current. Remember this point. Now this inconsistency can be studied. How it is studied? Let us take this current, what we are calling this current, we are calling conduction current. Right? Now outside this parallel plate capacitor, shall I take around this actually current is flowing, then around it magnetic field is produced. So the magnetic field I can take by taking imaginary line, imaginary loop I will take. This imaginary loop shall I take? I can take this value is C1. So how much current can flow? This much current can flow. Right around this. Then look at it. According to Ampere Circuit Law, wherever current can flow, magnetic field is produced. According to Ampere Circuit Law, what can take? Line integral of magnetic field around closed path. Line integral of magnetic field around closed path equal to mu naught times current flowing in closed path. What current exists? This current we are calling conduction current. This current we are calling conduction current. Like this it is. Right. Now for what loop it is? For the loop C1 I will take. Now shall I take this is what? This is the equation number 1 I will take. Outside the parallel plate capacitor. Now come to the point in between plates of capacitor. Point is in between plates of capacitor. Again shall I take? I will take again one more imaginary closed loop. Say this imaginary closed loop is equal to C2 value. Right or wrong? But remember, in between plates of capacitor, no current can exist. No current can exist. Then let us apply here Ampere Circuit Law. What it is? Line integral of magnetic field. Line integral of magnetic field is equal to again mu naught times into I. But in between plates of capacitor, no current can exist. So here no current between the plates of capacitor in what loop? In the loop C2. In the loop C2 is equal to I is equal to what value? 0. I is equal to 0. Wherever I is equal to 0, then what can take? So B into line integral of B into Z is equal to mu naught into 0 for what loop? For C2 loop. Look at me. This second of what? Equation number 2. Now you just compare equation 1 and equation 2. Here equation 1 and equation 2 both are not correct. Here also line integral, here also not integral. LHS are same, but what about RHS? RHS are not same. Because of what? In between plates of capacitor, no current can exist. So this is inconsistency in Ampere Circuit Law. What is inconsistency? Ampere Circuit Law unable to find electric field produced by conduction current. Ampere Circuit Law able to find magnetic field produced due to conduction current. But Ampere Circuit Law unable to find magnetic field due to changing in electric field. He doesn't able to find magnetic field due to changing electric field, but can able to find magnetic field due to conduction current. This is inconsistency in Ampere Circuit Law. I mean, Ampere Circuit Law only valid for wherever current is constant. I mean, electric field is constant. But wherever electric field is variable, there Ampere Circuit Law unable to find magnetic field due to changing current. This inconsistency was argued by James Maxwell. He argued that due to flow of charges, conduction current flows. Due to flow of charges, conduction current flows. But in between plates of capacitor, if electric field is variable, wherever electric field changes, electric flux also changes. Wherever electric flux changes in between plates of capacitor and current is produced, the current produced due to variable electric field between plates of capacitor, that current is called as displacement current. I mean, in Ampere Circuit Law, one more term is missing. That term missing we are calling displacement current. Are you following what Maxwell says? In between plates of capacitor, if electric field changes due to changing in electric field and electric current is produced, that current we are calling displacement current. Then I can define displacement current initially. Then how displacement current are produced, we'll see in detail. Look at me. Shall I define directly? Look at me. I can remove it, then I will discuss what is mean by displacement current. See here. Initially, I will define displacement current. What is mean by displacement current? Then what is expression for displacement current in detail? We'll see. Look at me, students here. What a displacement current produce? See here. The current produce. Due to changing electric field. Due to changing electric field. Between plates of capacitor. Capacitor is called as displacement current. Is called as displacement current. Now in detail we will see how the displacement current produced. Look at me. Displacement current is not due to flow of charges. How it is produced? It is produced due to changing in electric field. But how the conduction current produced? Conduction current produced only due to the flow of charges. Remember, look at me. Once again I will draw. Simple, I can take, this is nothing but parallel plate capacitor. I will take arrangement of two parallel plates. Simply I will take, this is one plate, second plate. Actually let us take current is flowing in between the plates of capacitor. If wire is connected, so this much current can flow. This current what you are calling conduction current, this we are calling conduction current, right? But wherever current can flow in the capacitor, on one plate positive charges are deposited, on one plate negative charges are deposited. Are you following? Wherever current can flow, more charges are deposited, so that electric field is variable value in between plates of capacitor. How the electric field produce? This is electric field produce, right around. What amount of electric field? This is the electric field. This electric field is always variable value. How this is? This is also variable value. So let us apply here Ampere Circuit Law. At this point, what is Ampere Circuit Law? Ampere Circuit Law, what you can take, line integral of magnetic field is equal to what value? Mu naught into I. Right or wrong? Remember this point. Then this Ampere Circuit Law valid only wherever current is constant. I mean electric field is constant. Wherever electric field constant, this we are calling conduction current. In Ampere Circuit Law, some term is missing. That term is due to inconsistency of Ampere Circuit Law. The term missing, displacement current is missing in Ampere Circuit Law. Displacement current is missing. So in this Ampere Circuit Law, around this, what Maxwell says, wherever electric field changes between plates of capacitor and current is produced, that current we are calling displacement current. How to take in between plates of capacitor, which current is flow? Displacement current can flow. Are you following this? And the displacement current, how it is produced? Wherever current can flow, more charges are deposited. Due to more charges are deposited, electric field always changes. Wherever electric field changes, electric flux also changes. Wherever electric flux changes, an additional current produced between the plates of capacitor, that we are calling displacement current. Remember, conduction current is due to flow of charges, but displacement current is due to only changing electric field, but not due to flow of charges. Right? Then, what is expression for this displacement current? Displacement current can be represented by what value? ID. I mean, we are going to correct Ampere Circuit Law. Ampere Circuit Law needs some correction because it is only valid wherever current is constant. But in between plates of capacitor, this current due to changing in electric field. Right? See here. We know that these are nothing but positive charges. Due to positive charges, this is one plate, infinite plane sheet. How much electric field is there? E1 electric field produced. For positive charges, electric field is radially outward. For this plate, how much electric field is produced? Look at the students. For infinite thin plane sheet, E1 is equal to what value? Sigma divided by 2 epsilon naught. That is Gauss law. Right? Then for negative charge, direction of electric field is inward. Inward value can be represented by what value? E2. Or what about this? This second E2 value. Right? This also infinite thin plane sheet. For thin plane sheet, what is E2 value? E2 value is equal to what value again? Sigma divided by 2 epsilon naught. Because for positive charge electric field radially outward, for negative charge electric field radially inward. Look at me, this E1 and E2 both are in the same direction. Then what is net E? Net E value. Net E value, how to write? Net electric field is equal to E1 plus E2. What is this value? E1 plus E2. I mean electric field due to positive charge, electric field due to negative charge. So look at me here. What electric field is produced then? Electric field changes by what value? Sigma divided by 2 epsilon naught. Right or wrong? Again what value? Sigma divided by 2 epsilon naught. What is net electric field between plates of capacitor? Net electric field between plates of capacitor can be represented by sigma by epsilon naught. Right on this. Then simply now I will call. Now let us take. This is nothing but equation 1 I will take. That is Ampere Circuit Law, where it is valid. Either it is valid here or it is valid here. But this Ampere Circuit Law not valid between plates of capacitor. Look at me here. But sigma is the surface charge density. Each plate has how much area? Each plate has this much area. Right or wrong? Then how to define surface charge density? Surface charge density is the charge distributed per unit area divided by epsilon naught. In between plates of capacitor, what electric field exists? In between plates of capacitor, this much electric field is produced, and wherever current is flow, this electric field is always variable. This electric field is always variable. Wherever electric field changes, number of electric field lines are changes. Then what is electric flux? That also changes, because we know electric flux concept. Electric flux is what? Number of electric field lines passes. That we are calling electric flux. In what way? Look at me. Electric flux I can define. Electric flux is equal to scalar product of electric field line area. Already know this quantity. Right or wrong? Look at me. Always electric flux changes. Look at me. This I can take equation 3. Put equation 2 in equation 3. What will get? Then phi is equal to how much? Phi is equal to Q into A whole divided by how much? A into epsilon naught. Right or wrong? This A get cancelled. Then what is flux? Flux is equal to what value? Q divided by epsilon naught. I can call this is equation number 4. I can call equation number 4, right? But here electric field changes. Wherever electric field changes, this electric flux also changes. Electric flux changes mean just to differentiate this equation on both sides. Look at me. Electric flux changes mean it is d phi divided by dt is equal to what value? 1 by epsilon naught is constant. Then how much? dq divided by dt. d phi by dt, rate of change of electric flux. Then I can take again this value. This value is equal to d phi divided by dt, 1 by epsilon naught, dq by dt, rate of change of charges between plates of capacitor. Wherever current is flow, more charges are deposited. With the time, more charges are deposited. dq by dt, this we are calling displacement current. Then again, how to write displacement current from this? Look at me here. id is equal to how much? Displacement current. Epsilon naught into how much? d phi by dt. Epsilon naught into d phi by dt. This we are calling displacement current. Then in Ampere Circuit Law, which term is missing? Displacement current is missing. It is produced due to changing in electric field, so that this Ampere Circuit Law equation can be modified. Modified equation I can write. Outside the plates of capacitor, conduction current exists. In between plates of capacitor, displacement current exists. So that Ampere Circuit Law can be modified in this way. Look at me. Ampere Circuit Law can be modified. That can written line integral is equal to conduction current plus displacement current. Right or wrong? Conduction current when it exists outside the plates of capacitor, displacement current exists between plates of capacitor due to changing electric field. Right? Again I can write this value, line integral of magnetic field, line integral of magnetic field, conduction current, displacement current how much? Epsilon naught into d phi divided by dt. This equation we are calling Ampere's Maxwell equation. Ampere's Maxwell equation. This we are calling Ampere's Maxwell equation. This is corrected term of Ampere Circuit Law. I mean, wherever electric field changes between plates of capacitor, and new concept arises that we are calling displacement current. Right? Then this displacement current, what is physical significance? This is important. We know that conduction current helps to find magnetic field due to conduction current. Magnetic field due to conduction current. But displacement current, it is able to find magnetic field due to changing in electric field. What is physical significance of displacement current? Physical significance is it helps to find magnetic field due to changing electric field. That is physical significance of displacement current. I mean, missing term in Ampere Circuit Law, what you are calling displacement current, and its expression can be given by this value, that id is equal to epsilon naught into d phi by dt. I mean, wherever electric field changes, magnetic field also produced. That magnetic field can be calculated by this current. This we are calling displacement current. The further concept we will discuss in the next session. Thank you, students.